Hello everyone, in this video we are doing some problems on dotted equivalent circuit. So this is the first question, that is we have to obtain the dotted equivalent circuit. So we have to find the direction of flux through each coil first. So the direction of current is shown like this, that means current is flowing in this direction in coil 1 and in coil 2 the current is flowing in this direction. So if we apply right hand thumb rule, then we will get the direction of flux in this coil like this, and the direction of flux in the second coil will be like this. So phi 1 and phi 2 direction we have obtained. That means both the fluxes are opposing each other. So now we'll draw the dotted equivalent circuit. So for that we can draw V of t plus minus. So we don't have to show the core in the equivalent circuit. So R, then the first coil, that is L1, so that is in series with the capacitor C, and now we can draw the second coil, that is L2. So this is a equivalent circuit, but we have not shown the dots over here, so we have to show the dots also, then only our circuit becomes complete. So the current is flowing in this direction through the circuit. So we have got that the fluxes are opposing each other, means the current should enter by the dotted terminal at one coil and the current should leave the dotted terminal by the second coil. So we can represent the dot over here in the first coil, that means the current is entering the dotted terminal at this coil, and in the second coil we can represent the dot over here. So it shows that the current is entering the dotted terminal of one coil and the current is leaving the dotted terminal of the second coil. So the dotted equivalent circuit is now complete. Now let us move on to the next question. We have to draw the dotted equivalent circuit of this figure. So in a core, 3 coils are wound, the self-inductances are shown and the mutual inductances are also shown. So these 3 coils are connected in series, as you can see. So let us consider current I flowing through the coil like this. So that current will be flowing in this manner in the first coil, and that will be going like this, and then it will be flowing in this direction in the second coil, and again the current will be flowing in this direction in the third coil. So in the first and the third coil the current is flowing in the same direction, and in the second coil the current is flowing in the opposite direction. Now we can find the direction of flux by applying right hand thumb rule. So we can see that in the first coil the direction of flux is like this. This is phi 1, and in the second coil the current direction has reversed, so the flux direction will also change. So phi 2 is like this, and in the third coil again the flux direction is like this. So phi 1, phi 2, phi 3, we have got the flux directions. Now we can see that the fluxes phi 1 and phi 3 are aiding each other, and the flux phi 1 and phi 2 is opposing each other. Also the flux phi 2 and phi 3 are also opposing each other. So we can draw the dotted equivalent circuit. So we can show the 3 coils in series. So the 3 coils are connected in series, and we know that the flux of the first coil and the second coil are opposing each other. So that means if I am putting the dot at this terminal, then the current should leave by the dotted terminal of the second coil. So I am putting the dot here. So the self-inductance of the first coil is J3 ohm, self-inductance of the second coil is J5 ohm, and the self-inductance of the third coil is J6 ohm. And we know that considering the second and the third coil, the fluxes are opposing each other. So here the current is leaving by the dotted terminal. So in the third coil, the current should enter by the dotted terminal. So this finishes the equivalent circuit. So we have to show the mutual inductance also. So the mutual inductance between the first and the second coil is J2 ohm. Mutual inductance between the second and the third coil is J3 ohm, and the mutual inductance between the first and the third coil is J4 ohm. So we are asked only to draw the dotted equivalent circuit. If you are asked to find the equivalent inductance, then we can find that also. That we'll see in the next video. So this is the dotted equivalent circuit of this particular figure. Now we'll see the dotted equivalent circuit of this figure. So let us assume a current to be flowing in this direction. So that current will be flowing in this manner through this coil, and through this coil the current will be flowing like this. The current will be flowing in this direction in this coil. So now if we apply right hand thumb rule, we can see that if this is the coil 1, this is coil 2 and this is coil 3. In the first coil, the direction of flux, if we apply right hand thumb rule, we'll get the direction of flux as in the upward direction or in the clockwise direction. So this is phi 1, the flux due to current in the first coil. Now let us consider the second coil and find the direction of flux, and we'll get the direction of flux like this, that is phi 2. And if we check upon the third coil, then we'll get the direction of flux like this, that is in the downward direction. But if we check all these three coils, all the coils are carrying current in the clockwise direction. That means actually these three coils are connected in series and current is flowing to the coils in the same direction also. So the fluxes are in the same direction. In this coil, in the first coil, the flux is in the upward direction. That means it is in the clockwise direction. In the second coil, the flux is in this direction. That is, it is also in the clockwise direction. In the third coil also, the flux is in the clockwise direction. So the flux direction is same in the three coils. So we can draw the equivalent circuit now. So first coil, its self-inductance is J5 ohm. The second coil, its self-inductance is J2 ohm. And the third coil having self-inductance of J3 ohm. So we can show the dotted terminals. This is A and this is B. This is the current flowing through the coils I. Now we can show the dot over here. The fluxes phi 1 and phi 2 are aiding each other. So we can represent the dots over here. The fluxes phi 1 and phi 3 aids each other. Phi 2 and phi 3 also aids each other. So we can represent the dots at the terminal where the currents are entering in the three coils. So self-inductance are shown. Now the mutual inductance between the coils is, this is J4 ohm. Between 1 and 2 is J4 ohm. Between 2 and 3 is J1 ohm. And between 1 and 3 is J6 ohm. So this is the dotted equivalent circuit of this particular figure. Now let's move on to the next question. So we are asked to find the dotted equivalent circuit of this one also. So let us assume the current to be flowing in this direction through this coil. So the current will be flowing in this direction. Now the current will be flowing in the it will be in the opposite direction. So the current will be coming like this and then it will be flowing in this direction through this coil. Okay, so the current direction is like this. Now we can see the flux direction. So let us consider the flux. Let this be the first coil and this be the second coil. Now we can apply right hand thumb rule and find the direction of flux in each of the coils. And we can see when we apply right hand thumb rule to the first coil, the flux is in the clockwise direction. This is phi 1. And when we apply right hand thumb rule to the second coil, we can see that the flux is in the upward direction. So we are applying right hand thumb rule to both the coils. So we have applied right hand thumb rule to the first coil and we have seen that the flux is in the upward direction, and we are applying right hand thumb rule to the second coil also, and again the flux is in the upward direction. That means here the flux is in the opposite direction, that is in the counterclockwise direction, and the first flux is in the clockwise direction. So the direction of flux in both the coils is opposite. So in order to illustrate this, we have to put the dots at if we are putting dot at one end where the current is entering in one coil, then we have to put dot at the end where the current is leaving in the second coil. So let's draw the equivalent circuit. So first I am showing the coil J5 ohm. Then there is a resistor having value 10 ohm. Then there is another coil of value of self-inductance J3 ohm. Then there is a capacitor of value minus J8 ohm, and all these are connected across a 50 angle 0 degree volt voltage source. So we have assumed the current direction to be like this. Okay, it's fine. Now the circuit is not complete. We have to show the dots also. So here we have obtained that both the fluxes are in opposing each other. That is the flux due to the first coil is the flux due to current in the first coil is in the clockwise direction, and the flux due to current in the second coil is in the anti-clockwise direction. So the fluxes are opposing each other. So if I am showing the dot at the terminal where the current is entering in the first coil, then I have to show the dot at the point where the current is leaving in the second coil. So this finishes our equivalent circuit. Thank you.